Hi guys, welcome to my Piecewise video function. I'm doing this quick video, a theory video, because I'm doing some problems that require us to understand what a piecewise function is. So this is going to be a little bit quicker video, and I'm just going to define a piecewise function and go through some examples of it. Okay, so what is a piecewise function? So let's start with the definition. Okay, a piecewise defined function is a function that is described by using different formulas on different parts of the domain. This is a piecewise function. Okay, so what does that mean? We have the y is equal to absolute value of x. Okay, this function can be expressed as a piecewise function. Okay, so let us do that. How can we express that as a piecewise function? Okay, the function is positive when x is greater than or equal to 0, and the function is negative when x is, the function is also positive if x is less than or equal to 0. Okay, so let's do that. So when x is less than or equal to 0, it's positive, and if x is greater than or equal to 0, it's also positive. Okay, so if x is greater than or equal to x, we could simply define this as x. And if x is less than or equal to 0, we need to turn it positive. We could do that by simply describing it as minus x. So if x is less than 0, minus 1 times minus is going to be positive. So it's going to be positive if x is less than 0. So there we have it, guys. We described y as a piecewise function of x. Okay? And we can draw it here. Okay? So how does that look like? Okay? So when x is greater than 0, y is equal to x. That is just going to be a straight line like this. And if x is less than or 0, it's going to be this segment of the domain here, and it's also going to be a straight line, right? It's going to be a straight line like this. Whoa, drawing lines on computers is hard, guys. But basically, these are both straight lines, and they're mirrored around across the y-axis. Okay, so that is one example of a piecewise function. Okay, now let's go to another example of a piecewise function. Okay, here we have a function that's already described to us as in different segments of the domain. Okay, so when x is less than 0, so this part of the domain, it's described by the function minus x. When x is between 0 and 1, it's described by the parabola x squared. And when x is greater than 1, it is described by it is described by x is equal to 1. Okay, so let us graph this. So let's get, we have three different functions describing the domain, so let's use three different colors. Okay, so let's start with the easiest. X is equal to 1. So x is greater than 1, x is equal to 1. So x is greater than 1, x is equal to 1. So we'll just go like that. Okay, and between 0 and 1, it's x squared. So we know how x squared looks like between 0 and 1. That's just going to be a parabola starting from here. Okay, and then when x is less than 0, it's going to be minus x. So minus x is simply just a function, that a straight line that's intersecting. Let me draw that a little neater. A straight line that's intersecting 0 and yeah, if y is equal to minus x. So when x is less than 0, we have the y is equal to minus x. If x is between 0 and 1, we have f of x is equal to x squared. And if x is greater than 1, we have f of x is equal to 1. Okay, so even though this is described in three different functions for three separate domains, f of x is considered one function. Okay, it's not considered three functions, it's still considered one function. It's just described by three different formulas in different parts of the domain. Okay? Okay, so that's it for that. Let's go on to our next problem. Okay, so sometimes we're going to be given a graph and we're going to be asked to find the um, find the corresponding piecewise function. Okay, so we could see that this is probably going to be a piecewise function because there are two lines and they're not really connecting, right? So they're probably going to be described by two functions. So in order to find the equation, find the formulas for the line, we're going to use a very known formula called y is equal to mx plus b. Okay? Let me change color. I'll go to black. So we're going to use the formula y is equal to mx plus b. Okay? So we are going, the m is called the slope of the line. Okay? And b is the y-intercept of the line. The formula for the finding the slope is the change in y, delta y, okay, delta means change, divided by the change in x, delta x, okay? And the b, to find b is when b occurs when x is equal to 0, okay? Because b is where the line intersects the graph. Okay. All right. So now that we b is where x is equal to 0. Where x is equal to 0. That's what b is. Okay. So using this formula, let's find the equation of the line. So in order to find the equation of the change in y and the change of x, we need to know some points on the line. Okay. And we have them. Right? We have them. So let me jot those down in a different color. The first point here is the point x is equal to 2, y is equal to 1. And the point here is x is equal to 1 and y is equal to 0. X is equal to 1, y is equal to 0. And then we have 2 points for this line as well, right? So let's jot those down. So I'll use a different color. So let's, for this line, we have the point 0, x is equal to 1, y is equal to 1. All right, we have the point x is equal to 1, y is equal to 1. And here we have the point x is equal to 0 and y is equal to 0. So we have 2 points. Let's find the m. Okay, so we have to find two equations of the line here and the line here. So with green, I'm going to solve for the line here. Okay, so first we need to find the change in m. Okay, so we'll call it m1 for the first line. Okay, so m1 is equal to the change in y. So the change in y is 1 minus 0. And the change in x is 1 minus 0. Okay? So then we could plug that into our function. So we plug that into our function and we have y is equal to 1 times x plus b. Okay? So now we have to solve for solve for b. To solve for b, we can just plug in one of the points from the line. We could plug in the points let's plug in the point 0 and 0. So we plug in 0 is equal to 1 times 0 plus b. Okay? So then this equation solves to 0 is equal to b. So we found the equation of the first line, guys. So the equation of the first line is y is equal to mx, which is 1 times x, or just x, plus b, which is equal to 0, which we won't write. Okay, so now let's find the equation of the second line, guys, and we'll do that in blue. So the second line, we'll call it M2. And technically, I guess I should call this B1, okay, because it's the B of the first line. So this is B1. So M2, let's find the slope. Okay, so we need to know the change in y divided by the change in x, right? So the change in y is 1 minus 0 divided by the change in x, 2 minus 1. So this is also equal to 1, right? So let's plug that into our formula. So now it's y is equal to 1 times x plus b2. Okay, so now let's just plug some points in here. So let's plug in the point 1, 0. Okay, so y is equal to 0 is equal to 1 times 1 plus b2. And this, guys, solves to b2 is equal to 1 times 1, and we bring it to the other side, minus 1. Okay, so now we found the solution of the other line. So let's write that. So y is equal to m, which is 1, so we don't have to write it, times x plus minus 1, which is b2. So we'll just write it like this. Okay, so now we found the two lines that represent the piecewise function in the two different domains. So now we could just go ahead and write that. So we have our two domains. Our first domain is 0 less than x less than 1. Okay, and why am I doing less than 1? Why am I doing less than 1? And here it's 1 less than or equal to x less than or equal to 2. Why am I doing less than 1? It's because of this open circle here. This open circle means that the point 1, 1 it discontinues from the point 1, 1, and it goes to here. Okay, the point 1, 1 is not on this part of the domain. It's not described in this formula. It's described in this formula. So that's why I'm writing it at the bottom. Okay, so then we'll write the line associated to this domain, which is x minus 1, and the line associated to that domain, which is x. Okay, and then we will just close it up with f of x. So this is the piecewise function number 3, guys. Okay, so just a quick little video, guys, just to help you understand what piecewise functions are. I'm using them in the problems, but I don't think I covered them in the theory, so I guess it's not really fair to use something that I didn't show. So there you go. So please let me know what you think of my videos. If you have any comments or any questions, please don't hesitate to write them in the comment section below. Thank you for watching, guys, and take care.